In this new section, we're going to talk about area of circles and area of sectors of circles. The first thing we'll start off with is the formula for the area of a circle. Until you take calculus, you have to believe me and your teachers that if you have a circle, the radius is r, the area of this circle is pi r squared. And if r has some units, and when you square it, you're going to get units squared. When you square r, which is r feet or r meters, you're going to square the units. So once again, area is in square units. Now, what happens if we're going to just take a slice of the pie? This slice right here. I'm going to take that portion. How much area does it have? And suppose it's theta. Well, the area, so this is called the sector. That's called the sector. And the area of the sector, it's a portion of the whole area. And suppose I tell you this is 4 inches. Well, the whole area is pi times 4 inches all squared. And now, if I tell you the angle, I tell you it's 30 degrees, well, we have 30 degrees out of 360. That's the proportion. 30 out of 360. The degrees cancel out. 30 goes into 30 one time, and 360 12 times. So you have 1 times pi, which is pi, times 4 inches squared, which is 16 square inches over 12. And 4 goes into both of these numbers 4 times and 3 times. And generally you say the number before pi. 4 pi over 3 square inches. So basically, this is the formula for a sector. Let's do it arbitrary. If the angle is theta degrees, then the area and the radius is r, then the area will be, the area of the sector is pi r squared times the portion, theta over 360. So that is your formula. The area of a sector is theta over 360 times the whole area, pi r squared. Do a few problems with this. Move on to the next section. You're taking a portion of the area. So, for example, let's suppose you have 20 degrees and the radius is 9 centimeters. 20 degrees, 9 centimeters. What is the area of that sector? So there are 2 parts. You have to find the area of the whole circle, and then you multiply by the portion that you're concerned with. The area of that sector is 20 out of 360. The area of that circle is pi times 9 centimeters all squared. Well, 20 goes into 21 times, and it goes into 360 18 times. So the top, you could ignore the 1. The top is pi times 9 centimeters all squared. 9 squared, centimeter squared. And this gets divided by 18. And 9 goes into both of these numbers. 9 goes into both of these numbers. 9 times and 2 times. So you have 9 pi over 2 centimeters squared. That is the area. Let me draw it again so I can shade it in. If this is 9 centimeters and in here is 20 degrees, I now know that area. It's square centimeters. About 15 centimeters square. Because 9 times 3 is 27. That's a little bit more than, pi is a little bit more than 3. So I made it 30. And 30 divided by 2 is 15. This is about 15 centimeters. You want a better approximation? Multiply it by pi. Problem is that there's no exact value for pi. Okay. Suppose you have a lawn, and the lawn is a rectangle. And since you want nice grass, you put a sprinkler, 2 sprinklers. You put one here, and you put one there. And they both have a radius of 3 meters. Okay, it squirts out water, or it throws water 3 centimeters, from 0 to 3 centimeters away. It sprinkles the water. And you have a similar thing down there. And once again, the radius is 3 meters. 3 meters, 3 meters. Well, we have a number of questions. How large is the lawn? How large is your lawn? That is, what is the size of the lawn? What is the size of the lawn? What is the size of the lawn? How much area is covered by the 2 circles? That is covered by the sprinklers. And of course that should be okay. And then the last question will be is, how much area is not covered by the sprinklers? That area, and of course what's in the yard. You may say the whole world, less those 2 circles. I mean, this sprinkler system most probably doesn't cover any portion of your property, but with respect to the lawn, how much of this lawn is not covered? Alright, so what is the total size of the lawn? Well, since it is a rectangle, it's going to be side by side. And each side is going to be in meters. Well, all the way across, that's 6 meters, 3 and 3. But that's the same as this. So one side is 6 meters. And same argument, this is 6 meters, and so is that 6 meters. So from down here to up here, That's 12 meters. Exactly how long that is. It's 6 meters by 12 meters, which is 72 meters squared. How much area is covered by their 2 sprinklers? Well, 2 comments. They don't overlap. The 2 sprinklers do not overlap. So it's just, just add up the area that each of the sprinklers cover. The first sprinkler, the top one, we know this is 3 meters, and it covers everything inside that circle. It's pi times 3 meters all squared, which is 9 pi. 3 squared is 9 times pi times meter squared. But you have the same for the other circle. So how much is covered by the sprinklers is going to be 18 pi meters squared. Now, how much is not covered? How much area is not covered by the sprinklers? Well, the whole area is 72 square meters. And if you take away what the sprinklers covered, you'll be done. And I can factor out a 9 from here. 9 times 8 minus 9 times 2 pi square meters. This is the amount of area that is not covered. It's just basic subtraction. You have the whole area. You have the whole area. And then you take away what the sprinklers cover. You take away the area that the sprinklers cover. And then you're left with what's in red. Okay, just basic subtraction will handle this. Okay. Let us try one more problem. It's a little bit fun. Suppose you have this big circle. Suppose you have this big circle. The radius is 18. 3, 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, 18. Okay. And I tell you, radius is 9 centimeters. And I drew a circle. So of course here is the center. I draw a circle like that. Then I draw another circle like that. And I shade this in. And then I do the same thing on the bottom, except it shifts a little bit. Go like that. And I go like that. And I want to know the area of that shaded region. Now, when you understand how it was designed, it will be a little bit easier. 9 centimeters. 9 centimeters is R. Okay. If you look at it very carefully, you'll see that what's in more bold-face red is equal to what's down here. They're the same area. So let's concentrate on the top, and I promise I will double it. Okay. So let us look at what's on the top. What would be good is to have this: 0, 3, 6, 9, 12, 15, and 18. This big circle, oh, okay. So now, let us look at it slightly differently. That's part of a circle. That's the top half of a circle. I mean, I could extend it down, but it's a circle. 3, 6, 9, the center of our circle, 12, 15, 18. That's the circle. At least the top half of a circle. But it's not all of this top half of the circle. Because if you look to the left for a moment, you have this arc. But that's also a circle. Goes from 3 to 6. That's also a circle. This part was taken away. You want to see the bottom half of the circle? You got it. It's just two circles. Now, what is the radius? So it looks to me like you have this big circle. Let me draw that a little bit better. You have this big circle. And then you have the little circle. And this is the area that's shaded in. Well, with respect to just the top half, it's just the whole area of the big circle, the top half of the big circle, minus the area of the little circle. But what is the area of the big circle? What is the area of the little circle? Well, the big circle goes from 0 to 12. That is, 6 is the center. 6 is the radius. So the big circle is pi times 6 squared. But it gets cut in half because it's only the top half that we are talking about. It's just that. But I'm going to take some of it away. I'm going to take away the area of the top half of the other circle, whose radius is 3. If the diameter goes from 0 to 6, the radius is 3. So I take away pi times 3 squared, and then I divide it by 2. The division by 2's cancel out with the 2 in front. So this is 36 pi. 6 squared is 36, minus 3 squared is 9, so minus 9 pi, for a grand total of 27 pi. That's the area in the top left figure for top and bottom. That's how much this area is, 27 pi. Now once you realize, and I'm not saying this was easy, but once you realize that the top half came from two circles, it came from this circle and that circle. And all you did was subtract the areas. This region that's black right now, it's exactly the top half in the first picture above this line, it's exactly the same area. So I subtracted the two areas, and then I divided by 2 because they were semicircles. Why did I double it? Oh, because I had the bottom half, which is the same as the top half. Okay, it's a nice problem. Should be able to do it. That pretty much completes the section on circles and sectors.